I'm Anil Kumar, sharing with you 3 excellent questions on rational functions from previous test papers. Question 1a. Solve the equation x cubed minus 3x minus 2 divided by x plus 1 equals 2, half x minus 1. Part B is solve the inequality, same equation, instead of equal to, less than equal to. Question 2. Write key characteristics and sketch the function x minus 1 times x plus 2 times x minus 4 divided by x plus 4 times 2x plus 4 times x minus 3. Question number 3 is write equation for the given graph. So this point here is 2.5. Let me write this point, and you can take some point here at 1, 2. Right, so that's not very clear from the graph. You could take these 2 points to find the equation of this particular graph. I'd like you to pause the video, copy these questions, solve, and then look into my suggestions. So let's begin with question number 1a. So we have x cubed minus 3x minus 2 divided by x plus 1. Clearly the restriction here is that x is not equal to minus 1. So whenever you work with rational functions, straight away write down the restrictions. Okay. Now to solve this, we can actually cross multiply, or since in part B we have inequality, I'll prefer to bring all the terms together so that we can use what we get here in the second part. Right? That's the whole idea. So I'll rewrite this function as, rather equation as, x cubed minus 3x minus 2 divided by x plus 1 minus half x plus 1 equals to 0. Now we can have a common denominator of 2 times x plus 1, right? So we have 2 times x plus 1. This term here gets multiplied by 2. So we get 2 times x cubed minus 3x minus 2. And this term gets multiplied by x plus 1. So we have minus x times x plus 1 plus 1 also gets multiplied by 2 times x plus 1. Right? So we have 2 times x plus 1 equals to 0. Let's expand and simplify. So we get 2x cubed minus 6x minus 4 minus x squared minus x plus 2x plus 2 divided by 2 times x plus 1 equals to 0. So let's simplify the numerator. We have 2x cubed, x squared, there's only one term, x minus x minus 1, that gives us minus 7x plus 2x gives us 5x, right? So minus 5x. Constants minus 4 and plus 2 gives us minus 2 over 2 times x plus 1 equals to 0. Now we really need to factor the numerator. It's a cubic equation. To factor this, what should we do? Well, we'll try some numbers which could possibly get us the factor. Numbers to try are factors of the constant term and the leading coefficient. So we'll try values for x equals to, let us say, plus minus 1, plus minus 2, and also plus minus half, right? For the numerator. We know already that there is one restriction, x is not equal to minus 1. So if I look into the value of this numerator, let me call numerator as nx, for different values. Let us say 1. If I substitute 1 here, I get 2 times 1 cube minus 1 minus 5 minus 2. So that is 2 minus 2 is 0. We get minus 6, right? So which is not equal to 0. So that is not of our interest. So let's try 2 now. So if I try 2, I get 2 times 2 cube minus 2 square minus 5 times 2 minus 2, which is 8 times 2 is 16 minus 4. This is minus 10 and minus 2. So that gives you a 0. So that means at 2 we have a 0. So one of the factors is indeed 2. So what we can do here is that we can do synthetic division or long division. Do one of these, whichever you're comfortable with. We'll do synthetic division. We'll divide by 2. That is the equation. Coefficients are 2, minus 1, minus 5, and minus 2. Let's bring down 2, multiply, we get 4, add them. So we're going to add them, we get 3, times 6, add 1, times, we get 2, and when you add, you get 0. So as expected, the remainder is indeed 0, right? So you could write this part as a quadratic equation, which is 2x squared plus 3x plus 1, right? Now let us see how we can factor this. Product is 2 times 1 as 3 and the sum is 3, so it could be done. So we could write this as 2x squared plus 2x plus x plus 1, and now we can factor this as, from these two we can take 2x common and you get x plus 1, and we already have x plus 1 here. Taking x plus 1 common, we can write this as 2x plus 1. So I hope these steps are clear. So what we did was, once we did synthetic division, we found that this term here, which forms a quadratic equation, can be factored as this. And therefore, we can now write this numerator here as 2 is one of the factors, that means x minus 2 times x plus 1 times 2x plus 1 divided by, we have 2 times x plus 1 equals to 0. Do you get it, right? So clearly, x plus 1 cancel out, right? That leads to a whole. So x is not equal to minus 1. So whole at minus 1. We need to solve the equations. That means the values of x, which will give us 0. So the answer here is x equals to 2 and x equals to, this will give you minus half. Do you see that? So these are the two solutions of the given equation. Perfect. So I'd like you to go through these steps, understand what we did here, and then we'll move on to question number 1b, which is the inequality, right? So let's go back and see. So this is our test paper, same equation but inequality. So we are going to use the factored form to solve the inequality, right? So that is the factored form which we are going to start with. So here is the inequality for us, part 1b. So I could rewrite this as x cubed minus 3x minus 2 over x plus 1 minus half x minus, becomes plus, less than equal to 0. And we found that this portion could be factored and written as x minus 2 times x plus 1 times 2x plus 1, right? Divided by 2 times x plus 1. So that becomes equal to 0. Perfect. This is what we did while solving question number 1a. Right? That's the equation. Perfect. And we are going to utilize this answer in solving the inequality. And that's the reason why we have question number 1 as part 1a and b. So I hope you understand and appreciate it. Now, since we have the factored form of our inequality, it's kind of simpler to solve. So what do we have here? We have a whole at x equals to minus 1. So we are going to analyze the intervals between, so we look into this, right? So minus 1, that is one value, which gives us a whole. And then we have 2x plus 1, which is 0 for minus half, so that's a 0, which could be a solution, and the last one 0 is 2, which is another 0, right? So we are going to analyze all these three, and then we'll write down our answer, correct? So let's analyze them here. So what we have here is 3 points to analyze. Let me make one here. So we have x equals to 2, which is a 0. Then we have x equals to minus half, which is also a 0. Then we have x equals to minus 1, which is a whole, right? Now these 3 points divide the whole interval into 4 portions, correct? So on this side, it is from minus infinity to minus 1. This is from minus 1 to minus half. And this is from minus half to 2. And then we have 2 to infinity, correct? These are the 4 intervals. Let's take test points in these intervals. We could take minus 2, 0.75 negative. Here we could take 0, and we could take 3 as our test point in the 4th interval. We are interested in finding the sign of this. That means we're looking for negative, right? Less than equal to 0, negative or zeros. So these are all the factors. Since x plus 1 cancel, so we can actually consider these 3 factors. I want to write 2 so that it is clear to you why, what really happens. You have to consider all the factors. So one factor is x minus 2, the other one is 2x plus 1, and then we have a factor 2. Now as you can see, if I substitute minus 2 here, this is negative, minus something means negative, 0 means negative, 3 minus 2 will give us positive result. For next factor, minus 2 gives us negative, minus 0.75, 2 times will be minus 3 will give us negative, 0 however will give us positive, 3 will give us positive. 2 remains positive, right? And the net result is when you multiply 2 negatives, you get a positive. 2 negatives gives a positive. 1 negative is a negative. And 3 positives gives you positive. So our solution lies within the interval minus half and 2. And since it is less than equal to, we'll include both the endpoints. Is that okay? So we can write that x is greater than equal to minus half and is less than equal to 2. Is that clear? So that becomes the solution for the given inequality. So I hope that makes sense, right? So that is the solution for the given inequality. Now let's do question number 2. Question number 2. Write key characteristics and sketch f of x equals to minus x minus 1 times x plus 2 times x minus 4 divided by x plus 1 times 2x plus 4 times x minus 3. Now we have a factor 2x plus 4. If I take 2 common, I get x plus 2, which cancels off, and we get a whole at x equals to minus 2, correct? So let me rewrite this function. We can write this function f of x as equal to x minus 1 times x plus 2 times x minus 4 divided by x plus 1. I'm taking 2 common from this factor, so I get 2 times x plus 2, and the last factor is x minus 3. So we have a whole at x equals to minus 2. That gives you a whole at x equals to minus 2. Okay, so first thing we consider here is a whole at x equals to minus 2. So we can find the value of the function at minus 2, right? So if I substitute minus 2 here, minus 2 minus 1 gives me minus 3 times minus 2 times this is minus 1. Here it'll get minus 6 divided by minus 2 plus 1 is minus 1. Minus 2 means 4, and that gets cancelled. So, what did I do? So basically, let's look into this once again, the numerator part. Minus 2 gives this, and this is 0. That gets cancelled off, right? So that gets cancelled off. So we have to look for this 2 actually. So we have this 2 times this. So we'll substitute here minus 2. So minus 2 minus 3 is minus 5. Does make sense to you? So we are substituting minus 2 here. We get minus 3 minus 6 in the numerator, and the denominator minus 2 will give us minus 1, and 2, the number itself, and minus 5. This could be simplified. So you get this divided, you get positive 9 in the numerator. Oh, I forgot to take this. Oh, there's a negative right in the beginning. So there's a negative. So we get negative 9 over, this becomes positive 5. Correct? So that is the position of the whole, negative 9 over 5. Close to 2, right? Okay. So good, we were forgetting this negative sign. There's a negative sign here. This is the negative sign. Okay. So we could write this function f of x now as negative x minus 1 times x minus 4 over 2 times x plus 1 times x minus 3. So we know x is not equal to minus 2, which gave us a whole. It's not even equal to minus 1 and 3. So these are the restrictions for the given function. Now we can find the x and y intercepts for the function. So for x-intercept is when f of x is 0. That means when the numerator is 0. So the x-intercepts are at x equals to 1, that is when this is 0, and x equals to 4. These are the two x-intercepts. Let's find the y-intercept. Y-intercept is placing x value as 0. So y-intercept you will get at, if I place x equals to 0, I get y equals to negative, this is this negative, times minus 1 times minus 4 over 2 times 1 time minus 3, right? So that gives you the value. 4 negatives makes it a positive. 4 could go divided by 2 is 2. So we get 2 over 3 as our answer. Correct? Now, all these values, let us put on a graph. And then we'll move forward. Okay? So we got quite a few values here. So let's say that's the graph of the function. Okay. So that's the coordinate plane. We have zeros at, well, we have some restrictions here. We have vertical asymptote at minus 1 and at 3. So let's say this is 1, this is 2, this is 3. So we have a vertical asymptote at 3. Then we have a vertical asymptote at minus 1. So let's draw this one. We have a whole which is at minus 2. So this is minus 2. Somewhere, let's say this is 1, this is 2 for us. Very close to 2. So let's say that is a whole, right? So let's make a whole here. Now let's look into the other information we have got. X-intercepts at 1 and 4. So that becomes one x-intercept. This is the other x-intercept. Y-intercept is less than 1. So let's say this is the point. Is it okay? So we get some points here. So let's call this as 2 over 3, the y-intercept. The x value, 1 and 4. This is the curve, vertical asymptote, which is at x equals to 3. And this vertical asymptote is at x equals to minus 1, correct? And this whole, the value is minus 9 over 5. It is at minus 2, correct? So we got that much of information. Now, let us see the horizontal asymptote. Now, since the degree of numerator and denominator is same, the horizontal asymptote will be y equals to the coefficient of x, 1 in the numerator, 2, leading coefficient is 2. So we get this negative value of half, okay? So we have a horizontal asymptote at half negative. So we'll draw this here. Okay, so that becomes the horizontal asymptote. Now it is important to check the behavior near asymptotes, right? So let's check behavior near vertical asymptotes, correct? So let's try at -1. So if I'm looking for a value which is kind of so the function given to us is simplified version is f of x equals to this, right? So we're looking at this function. Now if I'm testing behavior near vertical asymptote -1 at x equals to -1. So if I go from the left side, that is on this side of vertical asymptote, so I have a value, let's say at so left side we write kind of, okay, let me not use the word limit, I have used it anyway, -1 negative. That is what I'm trying to say here is check the value on the left side, that is this side, -1.1 for example. So if I substitute x equals to -1.1, then what happens to these values? So we'll see. Minus remains minus, this is negative. If I put a negative value, this will be negative, this will be negative. So I get negative, negative. And in the denominator, 2 is okay, positive, always. This term, if it is more negative than 1, is negative. This term will be negative. So we have 1, 2, 3, 4, 5 negatives. So the end result is negative. So I have my function which is approaching negative infinity. Do you get this point? Well, let's repeat this for x equals to -0.9. That is to say, I'm approaching this time from this side. Is it okay? Less than -1. In that case, the value of the function will be, that remains negative. And here, if I write negative, both numerators are negative, okay. As far as denominator is concerned, 2 is positive, but this becomes positive, and this remains negative. So we have 1, 2, 3, 4 negatives. That gives us a positive value, and that means this is the behavior. You could also test the value using calculator. Perfect. So we have checked on both sides of -1. Now let's check for x equals to 3. So now we'll check the fx value for x equals to 2.9, let us say, right? Now, if I substitute 2.9 here, then we have already a negative. This is this negative. Then 2.9 will make this positive, that is negative. Positive, negative, divide by, this is positive, this is for 2. This will always be positive. For positive value, 2.9 will give us a negative value here. So we have 1, 2, 3 negative values. So if you are approaching from the left side, you are going to negative infinity. Now, if I try f of x for x equals to 3.1, in that case, this is negative. Let me rewrite here with a different ink. We have negative. This for 3.1, this negative. And then this will be negative. 3.1 will make it positive. That will be negative. So we have negative and positive. Divide by that. 2 is always positive. 3.1 is positive. This is also positive. We got 2 positives. So 2 positives means a positive, and therefore it is approaching like this. Do you get an idea? Correct? So that is how we can figure out. And once we know these points and the behavior, we can connect the lines and graph the function. Right? So let's see. Center portion is kind of like this. Do you see that? How it is going? Kind of like this. So that becomes the center portion graph. Here, that is the behavior. You have to go through the x-intercept and approach the horizontal asymptote. On this side, you have to approach the horizontal asymptote, go through the hole, leave the gap, and then continue to form the equation. So that is what you get as your function. So I hope that part is absolutely clear. Now, for all this calculation, behavior near asymptote, you could use calculator, okay? So that's fine. Now, we need to specify key characteristics. What are the other characteristics? Other characteristics could be, you could see this graph is always decreasing. Do you see? So it is never increasing. Okay, never increasing. Always decreasing in its domain. So let's write the domain first. So the domain of the function is x belongs to real numbers where x is not equal to -2, -1. And this asymptote, which is at 3. So these are the restrictions. As far as the range is concerned, as you can see, the center portion goes through the horizontal asymptote. So the range is y belongs to real numbers. There is no restriction on range. We found that it is never increasing. However, it is always decreasing in its domain. Do you see that? In its domain. That means everywhere except for, those are the restrictions. Is it okay? So if I write always decreasing in its domain, let's write always also here. Then it suffices. You don't have to mention -infinity to -2, -2 to this and that. Okay. I hope that's clear. Perfect. So that is how you could really answer this question. Now you could also provide information when the function is greater than 0. That is, when is it positive? So it is positive in the interval from -1 to this x-intercept, which is at 1. So you could write this interval at from -1 to 1. It is positive. It is also positive from 3 to 4. So you can say from 3 to 4, right? Not including those points. When is this function negative? That is less than 0. It is less than 0 from -infinity to the point -2, and then from -2 to -1, correct? And also from this point, which is 1 to 3, and also from 1 to 3, correct? So that way you can give a lot of information about the given rational function. So I hope that makes sense to you, right? So last but not the least, let's write down x for the axis, f of x for the y-axis. That's the origin, correct? So that is how you should actually describe the rational function and all its characteristics. I hope that makes sense. Right? Let's move on and do question number 3. Question number 3. We need to write equation for the given graph. Now this graph is of a rational function. There are no vertical asymptotes. So that reminds you that you could write a function f of x as equal to something over x squared plus a. Now that will give you always non-zero number in the denominator, correct? Now we could say b as numerator and find the value of b and a using a couple of points on this particular graph. One of the points of our interest should be the maximum value at x equals to 0, which is at 2.5, right? And the other point is at 1, the value is 1, 2. So those are the two values which we can use to find the equation of the graph, correct? Since there are two unknowns, two values will give us the equation of the graph. So if I write x equals to 0, that means f of 0 will be equals to, which is 2.5. Here if I substitute 0 for x, I get b over a equals to 2.5. And we can write b as equals to 2.5 times a. Let me call this as our equation number 1. Now to get the second equation, let's write 1 for x value. And if I write 1 here, I get b over 1 plus a, and that should be equal to 2, right? That is the y value. Now we can always substitute 1, the value of b in this equation, right? So let's call this as equation 2. So if I substitute b equals to 2.5a here, I get 2.5a over 1 plus a equals to 2. So we have an equation in a, we can cross multiply, solve for a. So we have 2.5a equals to 2 times 1 plus a, which is 2.5a equals to 2 plus 2a, right? So we can now take all the terms on the left side and simplify. So let's rewrite this, right? 2.5a, let me write here, 2.5a minus 2a equals to 2, correct? That means 0.5a equals to 2, a equals to 2 divided by 0.5, which is 4, correct? 0.5 is half, so a is 4. If a is 4, we get one answer, right? A equals to 4. We can substitute this value of a in this equation, find b. So b equals to 2.5 times 4, which is 10. So we get the value of b as 10. And now we know our function, so we can write down the function f of x as equal to 10 over x squared plus 4, correct? So that is our answer. Perfect. So that is our answer. F of x is equals to 10 over x squared plus 4. You can verify using these 2 points if they satisfy the given equation. So that's how you're going to do question number 3. I hope you find this exercise interesting and useful. These were one of the best questions on rational functions from previous test papers, and I hope you enjoyed learning the way we have solved it. Feel free to write your comments and share your views. If you like and subscribe my videos, that'll be good. Share your test papers, and all the success to you. Thanks.